Good morning, ma'am. My name is Devi. I am from ECE. Today I am going to tell you about Schrodinger time independent wave equation. In this, we can go through introduction, mathematical formulation of Schrodinger's one-dimensional time independent wave equation, and finally we go through the conclusion. First, we can go through introduction. The introduction of Schrodinger time independent wave equation is: the Schrodinger time independent wave equation is a fundamental equation in quantum mechanics. It describes the behavior of a quantum mechanical system in terms of wave functions. The equation is named after Erwin Schrodinger, who developed it in 1926. The wave equation represents the energy of a particle in terms of its wave function. And according to de Broglie hypothesis, the particle in motion is always associated with a wave. To describe the motion of the particle in terms of its associated waves, Schrodinger derived a wave equation which is termed as a Schrodinger wave equation. And we can go through the mathematical formulation. Consider a particle of mass m moving with a velocity v along in the direction of x direction. It is associated with a wave. The displacement of the wave is given by the function of psi. Since the wave function depends upon the x coordinates of the moving particle and time t, it is given by the complex form psi of x comma t is equals to ae I of kx minus omega t. Write it as equation 1, where a is the amplitude and this is the diagram of the wave, and here the wave is going in the direction of x and with a velocity v, and differentiate equation 1 with respect to x. Then we get d psi by dx is equals to ik a e power I power I of kx minus omega t. It written as equation 2. Again differentiate equation 1 with respect to x. Then we get d square psi by dx square is equals to ik into ik a sin e I of kx minus omega t, and then d square psi by dx square is equals to I square k square psi. It written as equation 3, where psi is equals to a sin e I kx minus omega t. As we know that I square is equals to minus 1, then the equation can be written as d square psi by dx square is equals to minus k square psi by psi. Then d square psi by dx square is equals to minus of 2 pi by lambda whole square psi. Then here k is equals to 2 pi by lambda. Then we get the d square psi by dx square is equals to minus 4 pi square by lambda square into psi. It considered as a equation 4. De Broglie wavelength associated with a particle is lambda. Lambda is equals to h by mv, but we want 1 by lambda square. So n square v square by h square, and then we write the equation as 2 by 2 into m into v square by h square. Then 1 by lambda square is equals to half mv square into 2m by h square. As we know that half mv square is equals to ke. Let E be the total energy of the particle and V be the potential energy of the particle. Then kinetic energy is equals to half mv square. But kinetic energy is equals to E minus V. But E is equals to ke plus V. And here kinetic energy is equals to E minus V. Substitute the value of ke in A equation. 1 by lambda square is equals to E minus V into 2m by h square. Write it as equation 5. Substitute equation 5 in equation 4. D squared psi by dx square is equals to minus 4 pi square into E minus V into 2m by h square psi. D squared psi by dx square is equals to minus 8 pi square m into E minus V psi by h square. It can be written as d squared psi by dx square plus 8 pi square m E minus V psi by h square is equals to 0, and we know that h cut is equals to h by 2 pi. Then the equation can be written as d squared psi by dx square plus 2m by h cut square E minus V psi is equals to 0. The above equation represents Schrodinger one-dimensional time-independent wave equation. But for three-dimensional motion of the particle, the above equation becomes delta square psi plus 2m by h cut square E minus V psi is equals to 0, where delta square is equals to d square by dx square plus d square by dy square plus d square by dz square. And we conclude from this, the Schrodinger time-independent equation is a cornerstone of quantum mechanics. It allows to describe and understand the behavior of the quantum mechanic system in terms of energy. By solving this equation, we can make predictions about the behavior of the particles and systems. Thank you, ma'am.